So almost 2 years ago now, I showed a video on repairing this motor on my CGE Pro from Celestron. And as I probably mentioned there, unfortunately, of course, Celestron discontinued the product, and Pittman, this was a custom motor for them, and they refused to make any more. And basically, when you look at the specs, you can tell why it was having the problem it was, which was that it was the brushes were melting. And that's because this is a 6 volt DC, so that would run through all of the H bridge to run off a 12-volt supply. And what that meant is that the current is very high compared to typically Pittman makes 12 to 24-volt motors. So they were just melting the brushes. The plastic would melt. And you can get in there, break it loose, and it works fine. And so I'd repaired this, but unfortunately in the process, the set screw that was holding this on, I finally had to drill it out, and in the process I managed to scratch, if I can show it again, managed to scratch the encoder disc. And right up here is where I scratched it and did a lot of work buffing and putting a coating on it to try to repair it. But it wasn't quite optically clear enough, and so each revolution you lose a count or two, and the end result was that while I was hoping that with the software that I was using for tracking, it wouldn't really matter if the absolute was correct as long as the plate solve would get you close and then could get you closer, but it still was drifting too far. So at that point, I gave up and pretty much shut the observatory down because we were starting construction on the new house. And so now I'm back to being moved into the new house and still trying to finish things, but getting the hankering to start doing some work in astronomy and want to get this scope going again. Now, the one alternative would be to redo this as a stepper based and replace this, but it would kind of look ugly on the mount. So the issue is that I just need a new encoder wheel. Unfortunately, Pittman, while they still sell the encoders or a version of the encoder that's a 512 count per revolution for this size motor, they don't sell them separately. They only sell them on a motor. So I would end up having to buy a, probably a $500 motor to get just the encoder to take it off and put a new wheel on. And I'm not going to do that. And so after going back and forth off and on for the past couple of years, I finally tracked down somebody who recommended that I talk to US Digital. And so these are the guys that I went to and found a series that's a 512 count per revolution, has a tiny little encoder wheel by comparison, and that encoder wheel is just a press fit unit. And unfortunately, since they're sized a little smaller, their hole pattern on the mount doesn't match the hole pattern from Pittman. And so talking back and forth to the guy, I was like, well, do I get one of these and just take and try to auger out or go to my little milling machine and carefully widen these holes? And he's like, well, make an adapter plate. Now, I'm not sure if I got enough shaft, but I went and I did the model and ended up deciding, well, I'll just 3D print me a little adapter plate. And so hopefully this is going to work. Basically, it's got the holes here with the recess to hold the screws and mount to the motor, which I've already tested, and the encoder just arrived. And so these are tapped holes to match the encoder, and they will actually sit right over this. So if the screw's a little long on the encoder, I'm still okay. I had to have it thick enough that I could get the head to be flush, but otherwise I should be fine. So I'm going to mount this up and come back and I'll show you that, and then we'll see about installing that encoder step by step. So here's my little adapter plate installed, and I'd sanded it just a touch on both sides to get rid of all the little burrs and stuff, especially after doing the threads where it had flared out a little bit. But gives me just a relatively small spacer. I still have a certain amount of shaft left there. And we'll go with the first step, which is mounting the base on from the encoder. So this comes in a nice little kit, although the first thing that happened trying to pop it open is that one of the screws popped out and fell on the floor, so I had to go chase that down. But you'll notice, so there's the part number. It's a 512 count. The 156 is the diameter of the shaft. And then the other numbers are whether it's single or dual ended and the way it's packaged and a few other things. The interesting thing is you can see the US Digital logo all over this. This was the thing that I don't know for sure if Pittman makes these themselves or if they pay somebody else, but there is literally no identification on any of this. So, finding this part, impossible if you just had it because you don't have any idea who makes it. Nothing on the case, nothing anywhere. So, US Digital, they are selling this as a product, so obviously they want to put their name on it. And so let's go ahead. So the first thing is this little base piece that mounts on my adapter now with the 2 screws that I have. So we will start there. And the other thing I'll show you, which we'll use here shortly, is this little spacer kit to get everything positioned just right on the system. And now, just like that, we have that little adapter, or that base plate mounted to my little adapter. And so now we get to follow the next step, which is to put the PCB in and get that aligned using the tool. Now at this stage is where I finally decided to go read the directions. I'd actually looked at the directions for a different version that I'd planned on getting, so it's slightly different. In this, I kind of thought that this is what it should have, and it does. So this tool is actually for aligning the base. So the idea is you put this piece in and you push it down tight in order to align this to the shaft so that this holder for the PCB is well aligned, so that will make sure the PCB is aligned. So you start there, then you tighten those 2 screws down. And so looking at it, looks like my tolerances on my 3D printed part were good enough that this is lining up nicely. So I'm just going to hold it tight and tighten those screws. So now that we're sure we have it lined up properly, now we get to put the PCB in. And I want to make it so that the connector is as close to where the connector on the other unit was on this side, so that when I mount this motor in like this, the connector will be coming out facing toward me. And so we'll set the PCB in there. You see those 2 little pins, those are going to line up with the 2 little holes that are in there. The 2 bigger holes actually sit over the screws. So apparently those are relief in case the screws were hanging out, or possibly even to remove the screw through the hole. That would be difficult, but possible. Now with the PCB in place, you can see up here at the top's the optical encoder, which we don't want to touch and get fingerprints on. The bottom's a little 4-pin connector. Now you'll notice that's different than the 10-pin connector that's on the old one, but you'll also notice there's only 4 wires. So Celestron was never using the differential output that this supported. They just had the A and B. Though actually they had the A and the B not. So I have a 50-50 chance of getting those 2 wires, the blue and the purple, in the right way on this. I'm going to try to marry the new data sheet for the Pittman part, or the data sheet for the new Pittman part, to the data sheet from US and see if I can match the polarity on the first shot, kind of give myself a better chance. Knowing my luck, though, I'll get it exactly backwards and have a 100% guarantee that I get it wrong. So, next step. And that is to use this little spacer tool and fully push it down, push the PCB down onto those 2 pins, and it should snap into place so that there's no gap. Now it's already tight, but it's not, or it's already close to the surface, but it's actually not staying there tight. So Now we should snap it in with that, and then we'll come back and do the final step, which is, or next to final step, which we put in the encoder disk on. The PCB doesn't actually completely latch down, so ideally what I would have is a good spot to set this thing upright so that it stays there, versus trying to hold it, because holding this and the camera is problematic. The other thing, which I wasn't sure about because I could never tell, the encoder wheel on the Pitman device is reflective. So it's just got the sensor just like this and it reflects. But this one is actually, you can see all the little slices. This is a through wheel. So they did a neat little trick here. They actually have a lens inside the cover. So this cover is a lot more important than just keeping the dust out of it. What they're doing is they're transmitting through the encoder wheel and back through this little lens. So that's actually kind of neat. It's got a little prism. So we've got even more optics going on in our telescope than we thought. So next step is to go ahead and put that encoder wheel on here and use that same tool to push that encoder to the exact spacing it's supposed to be. Now, as mentioned before, this is a press fit. So the idea is you get the encoder started on there and then use that same tool to actually push this down and get the spacing using the tool. So that's our next step. And so now with the tool held tight in place, and so it's holding the PCB down, and so those little dog ears on the tool essentially control the distance from the PCB to that encoder wheel. And with that, there's really no more pushing I can do. It's down as far as it goes. And we'll just kind of drop the tool off of there. And that's almost flush to the top of the shaft. So my spacer couldn't have been much thicker and ensured full engagement, but we are right there where we need to be. We would have had clearance regardless to the back of the case, at least according to their 3D model, but I really am pretty happy with that. Now, what I would like to do is sit here and spin the motor from the other side, but I don't have 3 hands, but I want to see that encoder spin. So, using a little bit of a trickery here with the holding of the camera, there you go. Man, that's a fine set of holes in that encoder. And so, last step, snap the cover on. At least last step as far as assembling this encoder. Now what I have to do is take these 4 wires and get them on a connector that would go there. And I suspect, because I think this is the same style and pitch of connector, I could probably just chop half of this off, but I have gone ahead and bought replacement connectors for this. Since I think they're the same style, I should be able to just pull the pins and get them in here. But I want to make sure, I'm going to go, like I say, double check the pin out here and try to make sure that I match the 2 pins that are the data pins with the appropriate polarity, so that hopefully first time out it will run and I won't have to pull this back off and reverse it to get it to count in the right direction. So here's the little Molex Pico Blade connector, just the housing. And like I say, I've got pins if I have to crimp, but I should be able to just pull these out and plug them into that housing and be done. Alright, so here's the data sheet for the Pitman, the E30, which is essentially what this is, a 30mm motor. So it has a 30mm unit. And here's the color code for their 10-pin connector. And as you can see, Celestron more or less followed the code because they used green instead of black, but otherwise it's white. and then it's blue and what should be violet light, but they have it violet. So what's odd about this is they're showing channel A and B as the center two. So if they had a 2-pin, you would just have the blue and the violet, which is what this should be. But what Celestron did is connected to blue and violet white. So they're using the channel B opposite polarity that's added in here. That's the equivalent of just flipping channel A and B on a non-differential encoder, because you've changed the phase of one of the two inputs. And so by changing that phase, you've just reversed the phase relationship of the counts. And that means that, okay, if I come over to the data sheet for this is the 4-pin. I've got 5-volt DC. That's got to be white. I've got ground has to be green. Now, my A and B are the ones that it's a 50-50 chance as to whether or not A and B not versus A and B are going to be correct. And what I was hoping was that Pittman would have bothered to give us this diagram. Because if they had given us A and B not, then I could have figured out which way this needed to go. Because what happens is when you're moving this way, you see rising edge on A followed by rising edge on B. Rising edge on A followed by rising edge on B followed by falling edge on A and falling edge on B. So it's the order in which these occur that lets you know. So if you're low here and you see a falling edge, you're going this way. And if you're low here and you see a rising edge, you're going this way. If you're high here and you see a rising edge, you're going this way. And when you go the other way, this order reverses. And so if I flip this upside down, then I've reversed the order, just as if I took and I flipped both of these with each other. And so the question is, do I make the assumption that Pittman defined A and B this way, in which case it's A and B not, and I should flip A and B, or did they define it differently? And I really have no way of finding that out of this poor one-page data sheet that they give you that has some electrical specifications but nothing else. So, unfortunately, I'm back to 50-50 chance, and if I make the assumption that this is truly, my luck is that if I assume this is A and B not, and it's A and B are defined like this, then I need to flip these. And my luck will be that no, it's defined differently, and that means I'll get it exactly backwards. But I'm going to assume that it's A and B not, and cross my fingers, and what'll happen is it'll just count backwards if I get it backwards. And then I've got to pull those two wires and flip them. So as you can see, these are the same type of connectors, and pin 1 is there on the left. And so I just have to pry up those little tabs, pull each of the contact pins out, and plug them into the corresponding slot there. And I've decided I'm going to attempt to reverse those. So we're going to say A is violet and B is blue. And cross our fingers. So now we have all the pins removed. There's always a question of what's the best way to lift those little tabs up. And, a small screwdriver should work, but frankly, that tends to be, without damaging it, tends to be pretty hard. So typically the tip of an X-Acto knife, I've found, is usually the easiest way to actually get under there. This one, the tip itself is completely broken off, but I was still able to get in there with this one okay. That way you can kind of get in and lift up carefully. And so now I just plug these into the new pin holder in the order that I indicated, and we're done. And there we are, all plugged in to the new connector, and I just plug that in and we're done. Now I'm going to actually go and double check on the scope. We know that this is supposed to be white is plus 5 volts and green is ground, But just in case, for some reason that's not, before I blow up this encoder, we're going to double check that. Now, unfortunately, it's been pouring rain here all day, or at least the morning, and then foggy and misty the rest of the day. So there's no opening up the observatory to try this, but I could at least power up the scope and see if I can figure out, does it think it's running the right direction? I don't know for sure if it'll just count wrong or if it will give me an error condition if it actually counts wrong. So we will see after a little while. I did want to show this connector actually installed though. Well, leave it to Celestron and Pittman to just ruin my day. As you can see, this motor will actually fit. But when I try to actually insert it, the angle is just enough that this little adjustment block is preventing me from being able to get the thing into place. So I'm going to have to remove this block and then come back later and readjust it probably, just in order to be able to get this in. And of course that's the tension block, I believe, that controls the tension on the worm gear up here. So much for my quickly hooking this up and testing it out like I wanted to. I mean, I can still test it, but I can't actually get it installed. And it's cold and wet and dark out here, so I'm not going to finish this tonight, but I figure I'll fire it up and see what happens. Okay, so now with the cable still disconnected, I've already checked to make sure that we're getting 5 volts where we're supposed to. I want to demonstrate what happens when you have no encoder. So I power it up, motor stays still, not a problem. But now, if I go to the hand controller, it wants to do a wake-up process. But if I tell it to move, it starts moving and it won't stop. And the reason it won't stop is because the encoder's not telling it that it's moving. So as far as it can tell, it's not moving, and so it doesn't stop. And so we have to turn it off. Back. So now with the encoder connected, we turn it on. And one of two things are likely to happen. It'll either continue to go because it's now moving the wrong way, it'll error out, or it will actually do what we expect. Note that it's not moving full speed. It's actually moving at speed 9. Rate 2. All right, so it looks like I guessed right because it's not complaining, it's truly monitoring the speed. So it's the feedback loop. It's reading the encoder and controlling the speed, because you saw that with the motor just on full, it was moving much, much faster. So I do believe we have this fixed. And once we can come up with a way to get the thing mounted past that bracket, then we should be in business. And we have a solution, albeit very close. Now, what we don't know is it truly giving us the same 512 counts per revolution that it was supposed to? Does that rate 9 look reasonable? Sounds kind of reasonable, but we will see. Okay, so I lied. I went ahead and took a look at this to see if I could get it loose. And it turns out, once you get all the junk out of the way of the box, you can see that there are essentially these 2 screws that are Loctited up in there that hold this assembly. So it's now rotating essentially around the screw here that tightens it. So as long as I don't move that screw, this tension remains the same, but I just have to get these screws back completely tight so that this is locked down to, there's a little black block behind. Let's see if you can see it from over here. Yeah, here you go. So I have to lock that down and make sure that's cinched, which the good news is you can see the angle there. So if I get that flat, then we should be good. And because right now with that loose, what's happening is you can see this whole mechanism wobbles. And that's because the tensioner is not putting any tension on it. So I've got to get that tensioner bolted down to re-engage that. And then we'll be set to put the rest of this back together. So now that I've put those two screws in and torqued them tight, you can see how that block is drawn up nice and flat. So I'm confident we're back to being aligned properly. And you can see there's just a little gap between the back of the encoder and this block, but that's plenty. And so we should now be at the same tension to the gear as we were. So I just put this gear on, and then I reinstalled the electrical block that I propped up out of the way up here. And we're actually ready to see this thing move. Not that I can do much with it tonight, but it's worth a try. Okay, and so now we've put the gear back on and tightened it, set screws really well. And we've gone ahead and slipped the outer housing, put a couple of the screws on. It has far more screws than it really needs, but nonetheless, we've got it on. And now we've got our connector here. First time I powered it up, I couldn't figure out why I wasn't getting power to the motor or the encoder. It's like, well, I kind of have to hook this cable up. So that's where everything comes into the box and then gets distributed out to, you got your limit switches and your sensor for your RA axis. And there we are. So power it up. Come over here and grab our hand controller carefully. It looks like speed 9. That's about what I would expect. Beautiful. Okay, so cost. $40, 40 and a half, something like that, plus shipping. So call it 55 probably by the time you get the shipping. Pittman will for 12 bucks, or not, sorry, not Pittman, US, what's their name? US Digital. So US Digital will sell you a pigtail with this connector made up, and you can get it whatever length. That's about 13 bucks just for one pigtail. These housings cost about 25 cents a piece or so. The problem is you still have to pay shipping on them of, 10 bucks typically, depending on who you're getting them through. So if you can get the housing cheap, you're in pretty good shape. But still, this is a complete repair of the encoder for under $100, which is pretty reasonable compared to what Pittman would charge if you could get it. And like I say, the motor, the issue we know now is related to this, the brushes melting. I bought an extra encoder in case I have to do this to the other one. Hopefully, if I have to get in there, I won't scratch it. But the question will be, the one thing I haven't looked at is how hard, if I needed to get back into this motor again, how hard is it to get that encoder wheel off of here without damaging it? Because it's very fragile being that thin sheet of metal. Same time, you can probably buy the encoder wheel from these guys separate. Probably still cost you 20 bucks at least. But anyway, so with that, we'll finish buttoning this up and call it a night. Thanks for watching. One last comment on this tight spacing before I button this up. If it wasn't for my spacer, I wouldn't have had this problem. And so the only thing, if I were not to have used that and were to just use the built-in holes, Would have changed where this connector is a little bit, but I could have spread those holes out. And since this comes with the spacer to align the plastic piece, I really don't have to be perfect on getting those holes at any particular position. I could have used the existing screw holes and just kind of wallowed those out a little bit. I wouldn't even have to precisely machine them to try to get alignment because I've got the alignment tool. So if I have to retrofit again, chances are I would just leave that off and modify the base plate here. But that said, it's in. I know how to get it out if I have to. It's just a bit more of a pain. And with that, we are done. Thanks.